Have you ever wondered if we could hop into a time machine and travel to any point in time we desire? Time travel, a concept that has captivated human curiosity for as long as we've been able to dream, would certainly make for an interesting reality. It's been a staple of popular culture, from H.G. Wells' The Time Machine to the beloved Back to the Future trilogy. It's a manifestation of humanity's desire to control the uncontrollable, to grasp the ungraspable, time itself. But what is time really? It's often described as the fourth dimension, a continuum in which events occur in irreversible succession from past to future. We are all travelers on this one-way journey, moving ceaselessly forward. But what if we could reverse the flow, or even sidestep it entirely? This is where the concept of bending space-time comes into play. According to Einstein's theory of relativity, time and space are not separate entities, but are interwoven into a single four-dimensional continuum known as space-time. Now imagine if we could bend this space-time fabric, creating a sort of shortcut or wormhole. This could, in theory, allow us to leap from one point in time to another, much like taking a shortcut on a long journey. Yet, this concept is not without its paradoxes. If we could travel back in time, could we alter the course of history? And if so, could we end up creating a paradox where we prevent our own existence? These mind-bending questions have puzzled physicists and philosophers alike, driving them to explore the very limits of our understanding of the universe. Sounds like stuff of science fiction, doesn't it? But could it be more than just a figment of our imaginations? Could it be a scientific reality? As we delve deeper into this enigma in the upcoming scenes, prepare to question what you thought you knew about time, and brace yourself for a journey into the unknown. Over the years, many theories have been proposed about the possibility of time travel. Perhaps the most famous of these is Einstein's theory of relativity. This groundbreaking theory introduced the concept of space-time, a four-dimensional fabric where time and space are interwoven. According to Einstein, the fabric of space-time can be curved by mass and energy, creating what we perceive as gravitational forces. This curvature can also theoretically create shortcuts through space-time, a phenomenon known as wormholes. Imagine threading a needle, but instead of thread, you're connecting 2 points in time. That's a simplistic way to understand wormholes, but let's not forget that these are purely theoretical and have never been observed. Yet, if they do exist, they could potentially provide a pathway for time travel. On the other hand, we have black holes, these cosmic behemoths that warp space-time to such an extent that time as we understand it ceases to exist beyond their event horizon. Some theorists suggest that black holes could act as natural time machines, though the immense gravitational forces involved would likely prove lethal to any would-be time traveler. Of course, it's impossible to discuss time travel without addressing the elephant in the room: paradoxes. The classic example is the grandfather paradox. What happens if you travel back in time and prevent your grandparents from meeting? Would you cease to exist? Or would a new timeline be created where you simply don't exist? This is a conundrum that continues to baffle scientists and philosophers alike. So, theoretically, time travel could be possible, but what about practically? While the theories may suggest the possibility of time travel, putting it into practice is a whole different ballgame. Let's start with the technological requirements. To build a time machine, we're talking about a device that could potentially manipulate the fabric of space and time. That's no simple task. Even if we were to follow Einstein's theories and attempt to create a wormhole, the technology needed to stabilize such a phenomenon is well beyond our current capabilities. Wormholes are unstable by nature and would require something known as exotic matter to keep them open. The catch? We're not even sure if exotic matter exists. Then there's the question of energy. Even if we could design a machine capable of time travel, the energy required would be astronomical, to put it mildly. We're talking about levels of energy so high they're currently beyond human comprehension. Some theories suggest we'd need the energy equivalent to an entire star or even a galaxy. That's a lot of AA batteries. And what about the physical effects on the human body? Traveling at speeds high enough to induce time dilation, as per Einstein's theory of relativity, could expose the body to lethal amounts of radiation. We'd also have to consider the effects of extreme acceleration and deceleration, which could prove fatal. Beyond the physical, we enter the realm of moral and ethical implications. The potential for paradoxes is staggering. What happens if you change something in the past? Could you erase your own existence? Would you have a moral obligation to change historical events, no matter how tragic? These are just a few of the hurdles we'd have to clear to make time travel a reality. Each one presents a significant challenge, and that's before we even consider the laws of physics as we currently understand them. So, time travel remains a distant dream, at least for now. But who knows what the future may hold? After all, it's said that necessity is the mother of invention. And who wouldn't want a shortcut through time? Despite the practical limitations, the concept of time travel continues to captivate our collective imagination. It's a concept that has been explored and reimagined countless times in the realm of fiction and pop culture. Take, for instance, the classic cinematic trilogy, Back to the Future. Here, time travel is portrayed as an exciting, albeit dangerous adventure. With the aid of a time-traveling DeLorean, we see the characters navigate through different eras, leading to a series of thrilling escapades. This depiction reinforces the notion that time travel could allow us to witness history firsthand, or even alter its course, albeit with potentially drastic consequences. Then there's the iconic British television series Doctor Who. In this narrative, time travel is used as a vehicle for exploring a variety of worlds and civilizations throughout space and time. The TARDIS, an unassuming police box, serves as a gateway to limitless possibilities. This portrayal emphasizes the idea that time travel could open up a universe of exploration and discovery. Let's not forget about literature. H.G. Wells' groundbreaking novel, The Time Machine, presents a grim view of the future, where humanity has evolved into two distinct species due to the effects of social inequality. This narrative suggests that time travel could offer a sobering glimpse into the potential outcomes of our current actions. In each of these instances, time travel is more than just a plot device. It's a lens through which we can examine our own society, our history, and our hopes for the future. It allows us to ponder on what-if scenarios and to confront our deepest fears and desires. It's a mirror that reflects our collective psyche, our fascination with the unknown, our yearning to change the past, and our hopes and anxieties about what lies ahead. In the realm of fiction, time travel is a tool that allows us to explore our deepest desires and fears about the past and the future. So, what does the future hold for time travel? As we continue to delve into the mysteries of the universe, our understanding of time and space steadily evolves. Quantum physics, for instance, is a field that's been making waves and pushing boundaries, fueling our fascination with the concept of time travel. One day, the theories and equations we explore might pave the way to a future where time isn't a linear path, but a vast landscape that we can navigate at will. However, it's crucial to remember that these are still theories, possibilities yet to be tested and proven. Despite the allure of time travel, the reality is that it remains a concept largely confined to the realm of science fiction. Nonetheless, the potential implications of time travel are profound, challenging our perception of reality and pushing us to think outside the bounds of conventional wisdom. To quote renowned physicist Stephen Hawking, "Even if it turns out that time travel is impossible, it is important that we understand why it is impossible." While time travel captivates our imagination, let's not lose sight of the importance of living fully in the present. After all, time is our most precious resource. It's a non-renewable commodity that we should strive to spend wisely. While we may not be able to travel through time, we can certainly make the most of the time we have. It's been a thrilling journey through the corridors of time, hasn't it? We've explored the enigma of time, scrutinized theories, and pondered the practicality of time travel. We've also delved into its depiction in fiction and pop culture, and speculated about its future. Remember, time travel is theoretically conceivable, but practically constrained by our current limitations. If you enjoyed this journey, don't forget to like, subscribe, and comment on what intriguing topic you would like to explore next. Until then, keep wondering, keep exploring.